So the question is, what is the oxidation state of gold in below complex? So in this complex we have to figure out the oxidation state of Au metal, that is gold. Now this, we have two metals basically, but you can observe that the environment of these two metals is pretty much same. So each and every ligand attached to these two metals, they have the same connectivity pattern. So Au first, if I give 1 to this and second to this, so these two metals are basically, they have same environment or identical environment. That means we can figure out the oxidation state of any gold metal present in this complex. So what we have to do, we have to figure out the oxidation state of Au metal in this given complex. So first of all, this Au is connected with this chlorine ligand. So Au is connected with chlorine. So if I have to figure out the oxidation state coming from chlorine, this chlorine will have -1 and this Au will have +1 charge. This is the basic way of finding out the oxidation state based on electronegativity pattern. So chlorine will have -1 charge and Au gold metal will have +1 charge. That means Au will have +1 charge coming from chlorine ligand. Now this Au is connected with another metal Au, and since the chemical environment of these two metals, they are same, so we can say that this Au will bring only zero oxidation state, or it will not bring any oxidation state, because oxidation state of both the metals are same. So basically we'll have 0 coming from this Au metal. Next is this ligand. Now if we'll take this Au metal and this hydrocarbon ligand, so if any metal is attached with hydrocarbon ligand, we can say this hydrocarbon will bring -1 charge and this metal will have +1 charge. Okay, this is the basic way of finding out the oxidation state when metal is connected with the hydrocarbon chain. That's correct over here, but the catch of this question is that this hydrocarbon ligand is actually a sub branch of the phosphorus ligand. So it's coming from a ligand which is having different central atom, and that central atom will definitely constitute a charge over here. So we have to figure out that what is going to be the total negative charge that this ligand, ethyl ligand, will bring. Okay, so if this ethyl, this is basically your ligand, phosphorus ligand, it'll have two, it is basically it has two ethyl ligands, two methyl ligands, like this. Okay, now what phosphorus basically comes after nitrogen and phosphorus, and basic valences of nitrogen and phosphorus is 3. Okay, basically for example NH3 and PH3. So if I attach one more hydrogen with nitrogen, nitrogen will have positive charge, and if I attach one more hydrogen with the phosphorus, so it will basically have positive charge. Okay, so in general what I want to say, if phosphorus will have 4 branches or 4 groups attached with the phosphorus, it will have positive charge. So over here also this phosphorus has 4 groups. Okay, so basically it will have this +1 charge. Okay, so if this ligand is actually connected to a metal and this ligand is connected to a metal, so in general if this ethyl, okay, it's an individual ligand, so it'll have -1 charge. But this is not the individual ligand, it's coming from a group, it's coming from a ligand. Okay, basic ligand is the phosphorus ligand, and this ligand is a branch of phosphorus ligand. So we can say this phosphorus is having +1 charge. Okay, now in general it will have -1 charge and -1 charge. Okay, let's say there is no phosphorus ligand and we have two ethyl ligands, so this ethyl ligand will have negative charge and this ethyl ligand will also give, negative charge to the metal. So this is how we can understand this concept. But now we have a central atom, that is phosphorus, which is having +1 charge. So what is the overall negative charge that this ligand is bringing? Okay, so this ligand is having, so let's say we have +1 charge from phosphorus and -2 charge is actually coming from these two branches. Okay, branches. So -1 charge is, -2 charge is actually coming from the branches, -1 from this branch and -1 from this branch. So overall negative charge that this ligand will give is actually -1, right? +1 -2 is -1. So actually this is the overall negative charge that this phosphorus ligand will give to the metal. So if negative 1 charge is right, is the overall charge, so we have to divide this overall charge to these two sub branches. Okay, so we can say that this is going to be minus 0.5 and this is going to be minus 0.5. So actually these two ligands are coming with minus 0.5 charge and minus 0.5 charge, the reason being positive charge on this phosphorus central atom. So if this minus 0.5 is actually the charge on the ligand, so it will give plus zero point 0.5 to the metal and plus 0.5 to the metal. Okay, so in general what we can say, this is Au. Okay, it's connected with this ligand, and chlorine, it's connected with this one more identical ligand and this Au. So this is the basic environment of this gold metal, and for this gold metal we have to figure out the oxidation state. So positive 1 from chlorine, right? Okay, minus 0.5 from this ligand, that means plus 0.5 from this ligand, minus 0.5 from this ligand, that means plus 0.5 from this ligand, and 0 from this identical gold metal. So overall charge on this gold metal will be plus 0.5 plus 0.5 plus 1 plus 0. Okay, so this will give you plus 2. So this is the overall oxidation state of a gold metal. Okay, so the oxidation state of both the gold metals would be plus 2. So this is how we can find out the concept. So what you can observe, the question is very simple. Just the important point over here is you have to be very careful while calculating the overall negative charge coming from this ethyl ligand. If this ethyl this particular ligand would have been normal ethyl ligand, then definitely it will give you minus 1 charge, it will give plus 1 charge to the metal. But this ethyl is actually a branch of phosphorus ligand, and phosphorus itself is having positive 1 charge, so it will give you minus 1 charge. Okay, you just have to figure out the overall negative charge coming from the ligand. That's how you're going to find out the oxidation state, and the oxidation state of the gold is actually plus 2 and not plus 3. Okay, if you'll take minus 1 charge from this ligand, you would have marked option D, but the correct answer is option C. Okay, I hope this question is clear to all of you.